Hello and welcome back. Today I'm going to be solving the second problem on NeetCode's 150, valid anagram. And apologies for people that have watched my last video. I just realized that the volume was a tad bit low, so I made sure to raise the volume. The problem statement is as given. Given two strings, return true if the two strings are anagrams of each other, otherwise return false. An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Here, in example 1, we are given two strings, race car and car race. And if we take a look here, we would end up outputting true. So let's go ahead and validate this here. So with race car, right, we are given two A's, two C's, one E, two A's, two C's, one E, and two R's. And for car race, we are given two A's, two C's, one E, and two R's. And you can see that these two values here are equal. So that's great. So what we would end up doing is we would return true. In the second example, we're given two strings, jar and jam. Jar has one A, one J, and one R, and then jam has one A, one J, and one M. And you can see these two are not equal. So we would then return false. Let's kind of think through a couple of use cases here that we should support. I imagine the one case that I always love to tackle is in the case of empty strings. You could see here we're given very basic examples of a valid anagram and one where it's not an anagram. But what would happen if we were given two empty strings? Well, simply put, this would just have nothing and this would have nothing. I guess I'll represent nothing as an empty string as well. In this case, I'd like to think that we would simply return true because there's nothing to compare to. So this gives us a good idea or understanding that the length of S must equal the length of T, and that's good information for us to hold on to. One thing that I ran through my last video was invalid strings or invalid input, but for simplicity, I'd like to think that we wouldn't be given invalid input, but it is always something that you should clarify and understand, because your solution would change to handle the input given by the user. So with that being said, let's go ahead and list some of our assumptions here. We're assuming valid input. We're assuming two strings, which may or may not be anagrams. What else is there? Are there other assumptions we need to make? The output will always be a Boolean value. Valid input would always be two strings. Okay. I think that's all I could really think about on the top of my head. Again, if I missed anything, feel free to leave something down in the comments so that I could keep getting better when working on these. So we have a base understanding of what an anagram is. We have a couple of ideas how this might work. I think the first thing that comes into mind is sorting. If we look at our top example here, you can see that we went ahead and sorted it. So what would this algorithm look like? First, we would sort S. Then we would sort T. Sorting S would yield us O, log of s, and sorting t would yield us O log t. Actually, this is sorting is like n log. Sorry, s log of s, t log of t. And then what would we do? 3, we would simply compare both strings. So which would yield true or false. So given this, we know that we are dealing with O or s log s and t log t. So the time complexity for this would be s log s plus t log t. What other ways can we solve this? Let's think about this. Another way to do this is by using a data structure like a map. So what we would do is we would initialize s map and t map. 2, we would iterate through s and count. Then we would iterate through t and count. And these would yield O of s. And this would yield O of t. So we initialized our s map and our t map, and we would iterate through s and count, iterate through t and count. And simply put, we would compare our maps, which would end up yielding true or false. I'm assuming this would be O of s plus t. Yeah, because we simply just run through s once and t once, and the s plus t. Sorry about that, that's my dog. But yeah, I don't know any other way to do this than this one. Or better, sorry, I don't know any other way to solve this problem besides sorting or using a map. And so let's go ahead and start using a map, or in Python known as a dictionary. So we know that we need to iterate through s and count and iterate through t and count. Fortunately, there is something in Python to help us out from collections import counter. So counter is a more advanced dictionary. We're given an input, it'll go ahead and count the letters for us. So let's go ahead and run that. So first we're creating our s count. Count equals counter s. So it'll count the letters for us. T count equals counter at t. And so this is initializing our s map. S and t compare our maps, which would end up yielding true or false. And then simply put, we can return s count equals t count. And all this is doing is just making sure that all the key values are the same, and if not, it would return false. I know this looks like very minimal code, but it's all thanks to using this counter built-in function in Python. So let's go ahead and run it. Sweet, we passed, and we passed there. Awesome. All right. So we went ahead and completed, which one was this one again? Valid anagram. All right, see you in the next one.